We are part of the Data Science Institute and ICDI, the Institute for Computational Data Insight. But basically, we're in the Data Science Institute. You know where it is?
No, I'm new of the university. So
Okay.
that's it.
If, for example, if you're in geospatial or you are in health sciences or radiology, so depending on what type of, how the data come, then you try to analyze it and process it. Okay, 1 minute. Okay, let's give us 1 more minute and we will start. Okay. Okay, I think we have a good number to start. Today we will be continuing on how to use all the large language models that are hosted in Hugging Face. And these are pre-trained models and that we can just, having an account over Hugging Face, we can make use of them. And there are different types of models for different tasks. And every task you will find different options. We will see later that we have sometimes hundreds of versions of models. So let me go to the notes. And we can find the notes in our site, ua-datalab.github.io. This is where all our learning materials are. And this is the site for our notes, exploring the LLM Frontier. And today, we'll be talking about computer vision. Last week, Enrique talked about NLP models. So today, we will address computer vision using transformers. Next week, we will do the multimodal large language models to do some different tasks. Okay. All right, so let's go to the notes for today. And I have a presentation that we will follow. Let's see. And this. So everyone is in this page. And then we will just look at the presentation. And I will start the slideshow. So computer vision, a lot has been done using computer vision, and there are several tools that have been developed through the years. And basically, now that we have Hugging Face and large language models, things are shifting towards using large language models to do some types of computer vision tasks. And computer vision, as we know, appears in different applications. And the idea is that a system or some software can try to make sense of some visual data and also try to extract some information, some meaningful information from this visual input. And the idea is that we want these type of systems to do ordinary tasks that we done before by hand. Come on in. So we are familiar, for example, we see autonomous vehicles driving or flying even. We see these types of systems applied in medical imaging when we're trying to analyze or trying to detect different applications. Like, for example, if you have a X-ray or some type of imaging and you want to detect some tissue, then you can write an algorithm to try to detect or find all the contrast, and you can set up a threshold in order to detect if there is some tissue that you are interested in. Computer vision also is using facial recognition. So now almost every phone has a facial recognition option. So you can log into your systems using facial recognition or go into a specific building. Also has been used in augmented and virtual reality, which is a lot of computer graphics and trying to replicate the real world, creating like digital twins. Computer vision is being used extensively in robotics because these systems have cameras and they try to understand what they're seeing, and based on that, they will take some actions. And also in retail, commerce, everything is being used with computer vision. Okay. So computer vision is part of what we call deep learning. And deep learning is a type of machine learning, but we have lots amounts of data, and we try to let the software system try to detect or take decisions just based on the data we input. For example, the task we can do using computer vision is image classification. So if I give several pictures to the system and the system is already pre-trained, the system can detect, for example, a picture of a dog if the system has been trained on dogs. Or you train it on different types of animals, then we have object detection, and the system can discriminate if there's a picture of a dog or a cat or different types of dogs. Or, for example, we can use it for pose estimation, trying to detect different parts of a body as it's moving in a video, and then try to do some tracking. Another task is instance segmentation. So the system can detect what is the background and also what type of objects are in this picture. In this case, there's dog 1, dog 2, and a cat. Or semantic segmentation the system can detect if there's some dogs and there's some cats in the picture and the background. Also trying to predict depth, since in 2D pictures, we have trouble trying to detect the depth of the image. We need to have like a stereographic vision in order to detect depth. So there's some algorithms that can detect depth using a 2D image. Okay. So Hugging Face, as we know, is a repository of different machine learning models. And these models are applied for different tasks. In the case of computer vision models, we have, for example, for doing image classifications, we have like more than 13,000 options of models that have been trained for specific purposes. And the models, the difference between different models may depend on the algorithm, the number of parameters, and also maybe for some model, they create different model sizes, so it can be run on different systems and environments. For object detection, we have almost like more than 2,500 models. These numbers are from last night, so next week they will be different. And for video classification, about more than 1,100 models. For image segmentation, 920 more. For depth estimation, more than 130. Text to image is very active, so we have more than 35,000 models that can be used for doing this task. Image to text, it's only 649. And this is on the right, you will see all the different types of tasks you can do in computer vision. Besides image classification, you can also do image to text, image to video, and conditional video generation, video classification, and so on. So there are different tasks you can do in computer vision, and these models are hosted in Hugging Face, and these models have already been pre-trained, so we can just use them as they are available. Please stop me if you have any questions or if I'm going very fast. Okay. So in Hugging Face, there are different models and different frameworks and computer languages or programming languages are used to create these models. And for example, if we just take a look of what is developed using PyTorch, there's a section in Hugging Face called Team, the pre-trained image models, and there's over 1,300 models that are written in PyTorch over Hugging Face, and you will see all these different models. As I said, it will come in different sizes and also for different architectures and these models are continuously updated. Or you can see that some of these models have been updated 90 days ago, etc. And you can find these models in this link for the pre-trained image models. Now, when we talk about computer vision, traditionally, neural networks have been playing an important role, and they are still being used. And there will be some tasks where people prefer to use some neural networks because the results are very satisfactory. In neural networks, the convolutional neural networks are the ones that has been used in computer visions, and they by themselves they learn complex patterns from large data sets. And in deep learning, we only give the systems a large amount of data, and the algorithm will try to detect or extract information. And in computer vision, we do the task like image classification, object detection, semantic segmentation, and the other tasks that we showed a little moment ago. So now with the availability of large language models, there is a shift. And with the success of transformers, so now we can use transformers to do specific computer vision tasks. And the transformers, as you know, you have to fragment the initial information. For example, last week when Enrique was talking about NLP, you took a phrase, and then the phrase you start separating by words, and the words can be separated by different endings, and every word goes and ends up in a vector database that the system will try to use for later trying to generate. For example, if I give a couple of, if I give a part of a sentence with a couple of words, the system will try to predict what will be the next word. The same thing in computer vision. The image is fragmented not in words, but in pixels, or a small image like 16 by 16 pixels or 32 by 32, and those images, small images, are sent into an encoder, and then the system will try to extract some information. And the advantages of the vision transformers is that we are not limited in size, so we can process images, and this sequence of patches will try to extract some relationship, and it will try to create from that model future images. And so vision transformers can outperform CNNs in some scenarios, but not always. And the type of frameworks or tools that we can use in computer vision, we use, for example, traditionally, OpenCV is a library that has been used for image analysis and is basically based on neural networks. But now we have Hugging Face transformers. And also these libraries, you will find different versions using different tools. For example, PyTorch is one of the frameworks we use in deep learning. And PyTorch is compatible with Python. And also there is another family of software program, which is TensorFlow. TensorFlow was developed by Google. PyTorch was developed by Meta, Facebook. And more people are using PyTorch than TensorFlow. And then every time you do deep learning, you have to be capable of handling all the underlying hardware. For example, we use GPUs and also CPUs. So there's additional tools. For example, in PyTorch, there's PyTorch Lightning that helps us how to handle all the GPUs and CPUs. We don't have to worry. The same thing if we're working in TensorFlow, we use Keras in order to handle all the hardware. Additionally to PyTorch and TensorFlow, there's other languages like JAX, developed by Google, and ONNX, developed by Facebook, which are also different tools, and some people still use these programming languages in specific models. So you will find, besides PyTorch and TensorFlow, some libraries will be written in JAX or ONNX. Okay. Now, how does computer vision work underneath? So this is a convolutional neural network, and you input an image. The image is fragmented in pixels or some small sequence of images, and then are sent into a convolutional sector. And then from there are some mathematical transformations applied, and then it goes to a neural network, and it's trying to classify if this image is either a car or a train or a plane or a ship, which already the system knows. So this is for classification. And we can see this, for example, from this image, which is the image of the number 8. And if you think about this image in grade scale, there will be some squares which are completely black, and some squares which are completely white, and some squares which will be some grade of shade. And you just assign the number of gray shade, and then you analyze this matrix of numbers, and then to this matrix of numbers, you start analyzing it pieces by pieces, and then for every part of the image, you will extract a single number, and from that information, you will try to reconstruct or identify another image that has the number 8 in it. In the case of vision transformers, they, if you remember from last week, you will find that how does a transformer work? Actually, I have it in the next slide. And this is how a transformer works. In the case, we have a phrase of words, like data visualization empowers users to, and the system will try to predict what will be the next probable word. So data visualization empowers users to create, but create has less probability than visualize, and then the word analyze has a lower probability. So the model probably will try to create the next word using whatever probability is larger. The same thing it does in visual transformers. but instead of words and a phrase, I have an image, and the image is fragmented in small pieces, and then each piece is sent to the attention mechanism, and then it will try to learn from that, trying to, like here at the attention mechanism, will try to see what words are, how words should be, what's the meaning of a word inside a sentence and what is the relevance of it. The same thing will be applied for the individual transformer case. Okay, so the same thing applies in visual transformers. You have an image, and the image is segmented in pieces, and then it will try to go to the transformer encoded, and then it will try to classify what type of image you're talking about. Okay. So vision transformers, as we show in the previous image, has attention mechanisms, has a vision transformer, and also all the images are transforming into a high dimensional data for trying to extract the information from a specific image. Okay. What are the advantages of vision transformers over neural networks? Well, in using transformers, you have the ability to capture global dependencies. Also, you have some flexibility in image processing, and the vision transformers have some advantages on performance. So sometimes it's less demanding just to apply a transformer to an image in order to create new images or to classify image or extract some information. Okay, and then having Hugging Face as a repository for vision transformers, then Hugging Face will give us pre-trained vision transformer models for doing different tasks, and also we can customize these models. We can train them if we have the hardware to do them, and also to access the all the Hugging Face models, we just use our API to extract the information. So Hugging Face also has a very large community of people that can give some support for people who are just starting in these tasks. All right. So so that's more or less in general what is the theory behind computer vision transformers. And what we will do now is try to do some example using a Jupyter notebook. And we will see three types of computer vision tasks. We will see one example of image classification using the model from Hugging Face from Microsoft ResNet 50. And also we will use a case where we do some object detection using the Facebook model DETR ResNet 50. And lastly, we will do an example of image segmentation using this model, Segformer V2 clothes, which is just a transformer that detects the type of clothing from a person, and it can make a segmentation of the image of a person wearing some clothes. So we can return to the notes. Just go escape. And then these are the notes. So we just saw the presentation, and I have a very general information about what is computer vision and what is it used for, some main computer vision tasks, and you will see a definition for each task. And also you can find different tutorials in Hugging Face, how to do image classification, object detection, semantic segmentation, instance segmentation, image generation, face recognition, pose estimation, and optical character recognition. So there are some tutorials there. And in those tutorials, you will find, sorry. Come on. Go forward. Okay, so you will find in some cases tutorials for image classification. You will find videos and also segments of code you can use. So Hugging Face has a lot of documentation that we can use in order to explore and learn more how to use Hugging Face for doing some computer vision tasks. Okay. And then you will find some other learning resources. So for example, Papers with Code, it's a very useful site because you will find what is the state of the art in each field. In case of computer vision, you'll find papers on segmentation, representation learning, classification, object detection, image classification, and then whenever you select a topic, let's say you're interested in doing tumor segmentation, and then you will find a paper that has some application written on it, and also you will find what libraries people use for doing tumor segmentation. For example, there's a lot of people who are using this Monai library, and you will find a link to the GitHub page where you can find the software. So it's a useful reference in order to see what people use in a specific case. And also, besides the algorithm, you will find data sets, and you will see examples how people have used this algorithm to do tumor segmentation. So a lot of examples. Papers with code means that you will see the paper, you will have the code, and you will have all the links to the software and data sets. So, and the same thing applies for all the different applications besides computer vision, NLP, medical, and time series, graphs, speech, audio, reasoning, computer code, adversarial networks, playing games, robots, etc. So that's Papers with Code. It's a good site. It's a good reference to have. And then you can find other online courses. So Andrew NG also has a very popular deep learning course, and you will find it. You will find the link here, or the course CS231N from Stanford on deep learning for computer vision, or even Hugging Face has different tutorials on how to do computer vision. Documentation-wise, we have the documentation from Hugging Face and the documentation from OpenCV, the other library that use yeah, most of the code will be in Jupyter Notebook in Papers with Code. We are going now to show a Jupyter Notebook for our case, and you will sign them. Just finish this tutorials and blogs. You will have different resources you can explore, and I always find a good reference this Aman AI, an overview of computer vision models. So you will find different links for different resources, different models. So it's very exhaustive list of resources. So you are not starting from scratch. And then general references. We have the official papers from how visual transformers were created. And also you will find other types of tutorials. So let's jump into our Jupyter Notebook for today. This Jupyter Notebook, you can open it in Google Colab. It's sitting on GitHub. And so this Jupyter notebook was written by Enrique Noriega, and I already have it here. So I'm going to run it. So how do you run it? You say file, open notebook, and then where is the notebook sitting? If you're sitting on GitHub, then you just give the address of the notebook, and then you just open it. But I already have it, so I'm just gonna cancel this. So this is the notebook. So you have to install first some libraries, and we use the command pip install. %pip install will just install. These are the libraries we're going to install. So we're going to install 4 libraries: transformers, the PyTorch image models, some data sets, and Hugging Face hub. And we are going to do a quiet installation, so not everything comes into the screen. So I'm just going to Shift Enter to execute, and I'll have some error, but it's only a dependency error, and the notebook will still work. Just a warning about different versions. So now it's installing. I just took the default Google Colab environment, so I'm not doing anything special. And once it's installed, then we can start working on our 3 cases. Okay. So it's complete. So now we go to image classification. And image classification, we're going to be also using some we are just using the CPUs. We are not going to be using GPUs for the moment, but you can use, you just change here your environment. Oops, let's see, cancel, think here. So I'm using just RAM and disk, and I can change the runtime, but I'm using just CPUs. I'm not using GPUs yet, and it runs. So now I'm going to import some dependencies. I'm going to import some sublibraries from transformers, and also I'm going to import PyTorch, and I'm going to import some data sets. And I'm going to be using this model from Microsoft ResNet 50. Let me open. Oh, I have it somewhere here. Here. So this is the Microsoft ResNet 50 from Hugging Face. It's a pre-trained image. It was trained on ImageNet at 1K resolution. The pixels are 224 by 224 images. And this is the description of the model, all the architecture, and how to use it. It will give you some example. So it's going to classify an image from the dataset COCO 2017, and there is some example code here. So we go back to our case. So we're using this model, and I'm going to use this function to read the model, and then I'm going to define the model. And then I'm going to load a data set. So in this case, we are loading this data set from Tiny ImageNet. This is the address. And then I'm going to execute. I'm just rerunning the notebook. And since this is image classification, it will tell me what type of image I'm going to explore. So it run. Okay, so now we are reprocessing the image. And this image is going to be 224 by 224 pixels, 3 colors, 1 image. And then we just run it. And shows here, looks like a what? The resolution is very low, but it has classified this image. Okay. So more or less straightforward. For object detection, we're going to be using another model. We're using this model from Facebook, DTR ResNet 50. And we're going to define the model once we have downloaded the model. Okay. Now, once it has done that, then we can execute the next cell. And it will try to detect objects. And yes. So we just defined the functions. And then we're going to fetch an image from the internet, from the COCO data set. And the image is going to be read using this function to open the image remote, execute. And then it will display the results. Okay, so from this cell, it says that has detected a remote control in this location with this confidence. So it has detected 2 remotes, 1 couch, and 2 cats. And these are the confidence and locations of each object. And then we just execute this part to show what the model has detected. So it detected 2 remote controls, 2 cats, and 1 couch. And these are the positions. Every object is bounded inside it's inside a bounding box. And that's the image that it was read from the internet, this one. Okay. Sorry, escape. That's the image that was fed to the model. And this is what the model detected. So it's detecting 2 remote controls, 2 cats, and 1 couch. Okay. And this is the confidence of recognizing or classifying remote controls, the couch, and the cats. And then we just show what is the image and what is the classification. Okay. But the model has been pre-trained. It's not starting from scratch. Now, we're going to classify another image. So I need to upload remember that in Google Colab, once your session expires, it will delete all the files you upload. So I need to upload this file, test JPEG. So I upload from my computer. Come on. Over here. Open. So I upload this file. So I check the path, and it will be this content test. So it will read this file, and it will tell me what's in the file. And it detects two objects, one person with confidence 0.976 in this location, and one dog with confidence 0.998. So I just use the same model, but different input. Instead of the two cats and the two remotes on the couch, a person and a dog, and it classifies it with good confidence level. Okay. Right. Another task will be image segmentation, and it will split the image into different areas that are semantically related. And we will be using this image from President Obama, which is located in this address. So we just load it into the memory, and then this image will be used for inside this model, which is called segformer P2 clothes. And that model, let me just remind you, what is it? This one, this model. It just detects clothes and separates the image by clothes. Okay, so this is one example, and this is the piece of code. So I'm going to go back, and so import these functions from transformers. I'm going to use matplotlib pyplot to plot, and a neural network from PyTorch. And I'm going to use the model will be just the model from Hugging Face, and I'll be using the image from President Obama, and it will just segment the image once it finishes. It has finished. So this is the segmented image of President Obama, and you can see this is his suit, hair, face, and the tie is there. Okay, so these are just three small examples. There's a lot of documentation in Hugging Face you can try and explore. If you are interested in doing something, remember always somebody has done it before you and has put the code somewhere. You just need to find the code and replicate their example, and then adapt that example into your case in order to achieve the task you're trying to do. Nowadays, it's very rare somebody has to write some code from scratch. So it's a good practice just to see if somebody else already has done something similar, and it will save you some time. And also just try to learn how to read code, and you will see try to identify the different parts of the code and try modifying it a little bit to see what else does it do, or if you break the code. So what is essential and what is not. So that's a very general overview of what is computer vision, and if you have any questions, please let me know. Yes.
So is there any vision transformer model that we can train on our local computers with CPUs, not with GPU?
If you have time, yes. I mean, it would take sometimes, depending on the characteristics of your hardware. There is a rule: how many RAM do you have, and what is the model size, and what operating system you are handling. So it may take a while to train it. Usually what you do is train it on a small model, and then you scale up. And as you scale up, then you just leave your notebook, go to the next level. The next level can be HPC or Cybers, and then continue. But yeah, if you want to explore and have a feel of how the model works, you start with a small size model or a small version of the model. Every model will have different sizes and versions, and try starting with a small one and then scale up. That would be, because if you're going to train a model, yes, but it will require resources. Now you can have a pre-trained model and then fine-tune, and then fine-tune is an additional training, which may require enough resources, or you can maybe have some success with what you have. But you always start small and then scale up. You don't have to have the 2,000 million parameters model to start. Okay. Another question? Okay. All right. Any questions from people online? Is there a way to adjust the number of epochs or learning rate in these examples? Yes, but you have to rerun everything from scratch. The idea is when you're training a model, you are adjusting the parameters. And when you take a pre-trained model, it has been already optimized. If you want to change something from the start, then you have to pre-train it. And what does it mean to pre-train a model? It will require lots of resources depending on the model. For example, to train the Llama 3 model from Meta required about 25,000 GPUs. And if you have $100 million additional in your pocket, that's what training a model does. So not everyone in their garage will be training models. Usually models have been trained by large companies like Meta, Microsoft, Google, OpenAI. But you can pre-train a small model. And if you have access to a couple of GPUs, it's okay. But once your model starts scaling up, then you have to be thinking, all right, how can I manage 1,000 GPUs? You have to start thinking about network issues, speed issues, heat, energy. So you need like a data center and not something in your garage. But you can learn how to train a model from scratch. Actually, there's a good reference. Training large language models from scratch. Come on. Sorry. The see what we do. So good references, for example, I don't know if I have it. I don't think I have it here. Yes, but there's ways you can train a model from scratch. Actually, there's a book. There's a book, How to Build Large Language Models from Scratch. I think it's out now. But yes, you can start from scratch your code and build a model and train it. And actually, there's a GitHub for that. Yes, there's a GitHub with all the code, so you can play with it, and it's a good reference. So I think here you're talking about fine tuning. See, Septon. Yeah. So you will find different notebooks with all the code and theory about it. So it's a good book to follow or to explore if you are interested in getting into the details. We, in this workshop, will be in the more advanced topics. Let's see. So this is our plan. So we are just first exploring Hugging Face as users, and then once we feel comfortable with Hugging Face, then we will try to run large language models locally using Olama, and then get into the details of how to have conversations in more formal with our large language model. So we will be looking at LangChain, and then we will be playing with two models, Phi3 from Microsoft and Gemini from Google. And we will use these large language models to get more, to extract more knowledge, or how to learn more tasks using these models. And then finally create an interface to interact with the large language model. And the last topic will be how to fine-tune a large language model using RAG. So it's a gradual path. And okay, so
Can I ask a question?
Yes.
Yeah, is there a paper that you can recommend or a video that explains precisely the mechanism by which transformers is so much superior to convolutional neural networks or just neural networks in general? So I've read the paper Attention is All You Need, and then I've listened to the video by Karpathy.
Yes.
He talks about a matrix calculation that for language translation adds up the significance of words that are more positions away from the last word to be able to add up the probabilities that the next word will be a certain word. But I still don't understand what the advantages of transformers. I still don't get it. I sort of understand convolutional neural networks from listening to Jeremy Howard's Fast AI courses, but I haven't found anything that does the same for transformers.
Nathan is doing a session on transformers
Next week.
at 2.
Next week, Mitun Paul will be talking about transformers
Okay.
in the 3 to 4 workshop, NLP.
Okay. All
Okay.
right. Yeah, I'll wait for that.
Okay, so that's what we have for today. Let me stop the recording.